Okay, we will continue our notes by talking about the next section, which is inscribed circles in a triangle. So we've already talked about triangles inside of a circle. This is the opposite. So our circle is inside the triangle. The property that we need to note here to help us solve these problems is that tangents that meet at a point are congruent. So it's kind of like the ice cream example that I talked about earlier. So you've got three tangents here. So I have this tangent and this tangent that meets at this point here. So these two pieces would be congruent. Same thing here. These two would be congruent. And then here, those two would be congruent. So that's what this property is talking to us about. So example 6 asks us to find the perimeter of triangle ABC. So circle is inscribed. So think about if this were my ice cream cone that we talked about earlier. If this side is 12, that side would have to be 12 because these two pieces are congruent. I know that this whole side is 30, so if I do 30 minus 12, that's going to give me 18 for this piece. Okay. These two are congruent, so I know that's 18. If this whole side is 26, and I know this much is 18, I'm going to do 26 minus 18. To give me 8 for this piece, which is also congruent to this side. So I already knew this side was 30 and this side was 26. For the perimeter all the way around, I needed AB. But I actually had to find each piece of the missing segment in order to help me figure out the complete side of AB. So now I know that 12 plus 8 gives me 20 for this side. Perimeter means add all of our sides together. So we're going to have 20 plus 30 plus 26. And that would give us 76 for our perimeter. So now we're going to start talking about secants, which was the other segment in the circle. And secants are lines that intersect a circle at 2 points. So for example, we had our tangent, which intersected at exactly 1 point. So this would be my tangent. The secant is going to intersect your circle at 2 places. So that's an example of a secant. Okay. So the first way we're going to talk about secants is to help us find angles in a circle. And there's 2 rules that we're going to work with here. And that is, we're going to find this angle on the outside of our circle. So if I'm looking for this angle on the outside of our circle that's created by 2 secants, because it touches the circle in 2 places, touches the circle in 2 places. So it's created this angle on the outside. So I call this the big arc and then the small arc. So here's our big arc. Here's our small arc. So the formula to find this angle, you're going to do 1/2 times, and we're going to say big arc minus small arc. So 1/2 times big arc minus small arc is how we'll find the outside angle. Then you have an example of where two secants, so again, touches the circle twice, same thing there, so it creates angles on the inside of your circle. So in this case, we're looking for the angles on the inside. So you're going to look at the two intercepting arcs. So I've got arc 1 and arc 2. Doesn't matter what you call arc 1 and arc 2. It's just the arc across from the angle that you're looking for. So to find this angle, it's 1/2 of arc 1 plus arc 2. So 1/2 of arc 1 plus arc 2. So it's kind of like you're taking the average. So if we look at our first example, it told us to find x. So look at your two pictures above. If x is here, that's an angle on the inside. So I need its two intercepting arcs. So I have arc 1 and arc 2 for the intercepting arcs for this angle. So to find this angle, we're going to say 1/2 of arc 1 plus arc 2. Again, it doesn't matter what you call arc 1 and arc 2. So if I add these together, I'm going to get 202, and half of that is 101 degrees. So that's an example of finding an angle that's created on the inside of the circle by two secants. If we look at example 9, it's like our first rule because we're looking for this outside angle. And again, it's 1/2 of the big arc minus the small arc. So here's my big arc, here's my small arc. So we're going to say 1/2 of 101 minus 39. So that's going to give us 62, and half of 62 is 31 degrees. Example 10 is a little different because if you look at x, it's actually asking you to find the arc from the intercepted angle, okay? So the arc. So it still matches our rule here. So we're going to look at what we know. I know that if this angle right here is 120 degrees, it's supplementary to this angle right here. So I know 120 plus whatever this angle is forms 180 degrees. So this is going to be 60 degrees. So I want you to think about the rule. The rule says angle is 1/2 of arc 1 plus arc 2. So we're going to sub in what we know. My angle is 60. Arc 1 I'm going to call x. Arc 2 I'm going to call 100. So I'm going to distribute. Half of 100 is 50. So I'm going to subtract 50. So we're going to get 10 equals 1/2 x. And then to get rid of that fraction, we would multiply both sides by 2. The reciprocal. So you're going to get x is 20 degrees. So I'm going to say that that's 20. So how could I check that? Well, you could go right back to your formula. You could add your two arcs. So 20 plus 100 gives us 120. Half of that would be 60. So you know you're correct. So for B, it's asking us to find that outside angle. So angle equals 1/2 of big arc minus small arc. I know my small arc. The big arc's missing. But you know that there's 360 degrees in that total circle. So we're going to say 360 minus the 70 minus the 55. So when we do that, 360 minus 70 minus 55 gives us 235 degrees for the big arc. So then to find my angle, I'm going to say 1/2 of big arc minus small arc. So again, big arc minus small arc, 235 minus 55. So that's going to give us 180. And half of 180 is going to be 90 degrees. Okay.